So let's get started with sentiment analysis. First, I'm going to load in data from our data directory. In here, there are two files, reviews.txt and labels.txt. These are just the text files for our movie reviews data and their corresponding labels, positive or negative. So I'm going to load these in and print out some of their contents. Here you can see some example review text that's talking about a comedy called Bromwell High. And here you see some of the text in the labels file, which just has lines positive and negative. And actually this looks like just one review, and I want to see if I can print out more than one. Alright, so here I've started printing out a second review here, and you can see that these two are separated by new line characters, much like positive and negative are separated by new lines. Now we already know that we need to pre-process this data and tokenize all of the words in our vocabulary so that we have numerical data to feed to our model later. Since we're using an embedding layer, we'll need to encode each word as an integer, and we'll also want to clean up our data a bit. The first pre-processing steps I'll want to take are turning our text to lowercase and getting rid of extraneous punctuation. Punctuation that, in this case, will not really have any bearing on whether our review is classified as positive or negative. Okay, so in this cell, I'm converting all of my review text to lowercase, and I'm getting rid of everything that is punctuation. And I'm using a built-in Python list here, which is from string import punctuation, and I'm going to print out what all is in there. So punctuation is just a list of all of these punctuation characters. Then for our reviews, I'm looking at every character, and if it's not in the punctuation list, I'm keeping it. This gives me a version of the review text that is all text, no punctuation, so I'm storing that in this variable all text. Next, I know that my reviews are separated by new line characters, /n. So to separate out our reviews, I'm going to split the text into each review using /n as the delimiter here. Then I can combine all the reviews back together as one big string. And finally, I get to my end goal, which is splitting that text into individual words. So I'll run this cell and print out the first 30 words. And it looks just as I expect. Essentially the original text that I printed out, only all the punctuation is removed, and we've separated everything into individual words. So our data is in good shape, and by now you should know what's coming next. We have to take our word data and our label text data and convert this into numerical data. Your first couple of exercises will be to create a dictionary, vocab to int, that can convert any unique word into an integer token. Then using this dictionary, I want you to create a new list of tokenized words. All the words in our data, but converted into their integer values. I'd also like it so that our dictionary maps more frequent words to lower integer tokens. One important thing to note here is that later we're going to pad our input vectors with zeros, so I actually do not want 0 as a word token. I want the tokenized values to start at 1. And so the most common word in our vocabulary should be mapped to the integer value 1. So create that dictionary, use it to tokenize our words, and then store those tokens in a list reviews ints. Below this, I provided some code that lets you sort of test your implementation. It'll print the length of your vocabulary, and it will print the first review in your tokenized review list. Your next and similar task is going to be to encode our label text into numerical values. We saw that this text was just lines of positive or negative, and I want you to create an array, encoded labels, that converts the word positive to 1 and negative to 0. I'm not providing any testing code here, but I encourage you to get in the habit of testing out your own code, piece by piece as you build. It's good practice and can be as simple as a few print statements to check that your data is converted as you expect, or that it's the correct size, and so on. These checks can really save some time later on, because these code blocks really build on one another, and it's good to debug early and often. Okay, so try encoding all of our words and labels on your own. And if you get stuck or want to check your solution, feel free to look at the solution video next.